Welcome you all to the lecture series of the DBMS subject from the AKTU course content. The course subject code is BCS 501. Myself will be you all with the help from ABES Engineering College, Ghaziabad, Assistant Professor. We're discussing about the transaction unit 4. In the previous lecture series, we have discussed about what a transaction as its properties, how do we can get the conflict serializable schedule, serial schedule, and many other things. Now, in this lecture, we are going to discuss about the very important points of the distributed database. How do we handle the distributed database, how it has been stored, and a very basic concept of the concurrency control. In the next fifth unit, all the concurrency control will be discussed. How we can achieve the concurrency control using the locking protocols, the time stamping protocols, and many other protocols. Okay, so let's start with the distributed database. By the name says distributed, we are distributing it somewhere. So what it says is a distributed database system consists of loosely coupled sites that share no physical components. Okay. So if you see this thing, a database system that run on each site are independent of each other. Now, if you see this, we have one database here, one database here, one database here. They're independent of each other because there is only one thing that is there is the communication channel. Now, what is the important point of doing it? For example, there is some kind of an issue on the hardware issue, the software issue at this site. Okay. So this location, this and this can work on this thing. Now, the important point, if you see this thing in this diagram, this is a location 1 here, this is a location 2 here is, and the location 3 is. So the geographical location is the main important point. So we are putting in different kind of this thing. Transaction may access data at one or more sites. So we can access from one site or the other site also. So this is a very important concept of these days, controlling of this power. Now we have two types of database. That is, first is a homogeneous database, another is a heterogeneous database software. Now, when we talk about homogeneous distributed database, all sites have an identical software. So they have everything in the same, are aware of each other and agree to cooperate in the processing using the user request. Each site surrender part of its autonomy in the terms of right to change the schemes of the software. So they are working in a homogeneous or in a similar manner. So they have a similar kind of a thing. Whereas in heterogeneous, we have a different site may use different schemes and the software. So that is a very important point. Difference in the schema is a major problem for every query processing. So this is a problem. Difference in the software is a major problem for the transition processing also. So these are the things that is not available, but still not used very frequently. So we can use for the homogeneous part rather than the heterogeneous part of the software. Now, how do we store it? So when we talk about the data storage, so when we talk about the distributed data storage, so it goes in a different point is we assume a relational model. What our application says, we're applying it. So we are doing a replica of it. So it's something, a copying of something. So we have a system here, we copy it and put it here somewhere in a system in a geographical location like this. So system maintains multiple copies of our data. See, copy number 1, then we can have a copy number 2, then we have a copy number 3, and stored in different sites for faster retrieval and the fault tolerance. So we are replicating it. Fragmentation. The relation is partitioned to several fragmentations stored in the distant sites. So we can do it in the two parts. First, we can replicate it, so by that, and we can fragment it in the breaking part of this thing. Okay. Replication and the fragmentation can be combined. So when we do both the things, the relation is partitioned into several fragments. System maintains several identical replicas of each fragment. So one system is, there is a system whole. So if we are doing the replica, we are creating a copy 1, this is a copy 2, this is a copy 3, and this is the original copy. Now this is the replica part. Now when we talk about the fragmentation part, so this has been divided into part 1, part 2, and part 3. So it is divided into 1 part, 2 part, and 3 part. Now this is fragmentation. Now when we talk about these three things together, we can perform this thing. So we have fragmentation, the several part, and then picking a copy of it. Okay. So when we're talking both the things, the fragmentation done first, then the replica is done. A relation or a fragment of a relation is replicated if it is stored redundantly in 2 or more sites. Okay. So when we're talking about a relation or a fragment of a relation is replicated if it is stored redundantly if it is stored redundantly in 2 or more sites. Okay, so if it is not there, we can proceed with the same thing. Okay, now the full replication of a relation is the case where the relation is stored at all the physical sites or the software sites. So we are replicating the full one. And a fully redundant says database are those in which every site contains a copy of the entire database. So see, there is a difference between a replica and a fully redundant part. So when we are talking about redundant part, we are getting a copy of an entire database where a relation is stored and copied in the all the replica part. So that is a very important point between the replication and the fully redundant system also. Concurrency control. Now this is a very important point. Now we have seen that in the overall fourth unit, we are dealing with the concurrency of our data. Now how do we ensure that how we can achieve this thing? To achieve this thing, we have different kind of algorithms and the locking protocols, like locking is there, timestamping protocol is there. So this will ensure that all the transactions which enter into the system are executed serially and are making a system in a consistent database part. So all the transactions which are ensuring these parts have to follow these algorithms, which will be covered in the next unit. I hope you have learned important points regarding this unit. So the overall unit will be consisting from the starting of the transactions, what are transactions, what are the asset properties, what are read and write operations, how do we perform read and write operations, what are conflicting instructions, what is a serial schedule, how we can ensure that a serial schedule is a serial schedule, that is by conflict serializability and view serializability. Then we go with the recoverable schedules. In the recoverable schedules, we have recoverable schedules or irrecoverable schedules. Then we have log-based recovery, checkpoints, deadlock handling, deadlock prevention, and the concurrency control. I hope you have learned important points regarding this. This is a very important unit which covers approximately 20 marks in your paper for AQT exam.